we need to find the imaginary part of this trigonometric function. The first thing we'll use is the exponential definition of cos z, which is half e to the iz plus e to the minus iz. So if we know that that equals that, we can now substitute it in, where z equals x plus iy. So now cos x plus iy would be half e to the I x plus iy plus e to the minus I x plus iy. All we've done is substituted this in and rearranged. So now we know that using the identity of I squared equals minus 1, we can simplify this out, because once we now expand this ix and I squared y, you can substitute in this minus 1. So I'm not going to rewrite that again. You're going to get half e to the ix minus y plus ey minus ix. The next step here is to now use Euler's formula. So where e to the ix would be cos x plus I sin x, and e to the minus x would be cos x minus I sin x. So let's start substituting in. If we know e to the ix is there and e to the ix is there, we're a bit stuck because we have these minus y terms in the way. But we know by remembering our rules when it comes to indices that this can be rewritten as half e to the ix minus y plus e to the y e minus x. So that is exactly the same as that, and now we can easily break this down. Now let's start substituting it in and making this a bit simpler. So we now know that half e to the minus y, where e to the ix is just this, so cos x plus I sin x. Then we have plus e to the y here, and e to the minus x, which is going to be cos x minus I sin x. We can now expand. And then you're going to get e to the minus y I sin x plus e to the y cos x minus e to the y I sin x. The brackets aren't really that necessary there. So let's now rearrange and move so we can get the coses together and the I sin x's together. So that's then going to become, and I can multiply in the half. So let's apply the half to absolutely everything. You're then going to get cos x e to the minus y plus e to the y over 2 plus I sin x, and then you're going to get e to the minus y minus e to the y divided by 2. So all I've done is just move these around, put together these two, so you get e to the minus y and e to the y. So I basically just swapped these two around, and then I've simplified it. I've multiplied the half in, so it's applied everywhere. We now know that through another hyperbole function, or the definition of a hyperbole function, that sine h y is e to the minus y minus e to the y over 2, and cosh y is e to the y plus e to the minus y over 2. Coincidentally, that looks a bit like that, and that looks a bit like, sorry, that looks a bit like that, and that looks a bit like that. So let's now substitute it in. So now we're now going to get cos x cosh y minus I sine x sine h y. And then we now want to look at just what is the imaginary part. So this is the real part. The imaginary part is everything that comes after the I. So that's here. So the imaginary part of cos z is going to be minus sine x sine h y, or they might ask you to write it as the imaginary part of cos x plus iy is going to be sine x minus sine x sine h y. Either one is fine. You could even just highlight this, but just remember that that's going to be negative. So there's quite a few identities, formulas to remember in this one. You need to be quite familiar. Some of them are given to you in your formula book. Some of them you need to remember. But with these kind of questions, the more practice you do, the easier it will become.